Welcome to Spring LIB.
Okay, so for this problem, we are given the equation alpha is equal to negative k times theta. And we know that alpha is our angular acceleration and theta is angular displacement. And we are also given that when theta is equal to 0, omega, or angular velocity, is equal to 12 rads per second. And when theta is equal to 6, omega is equal to 0 rads per second. And the equation we're going to want to use to solve this problem is right here. Okay, this is a basic dynamics equation. And basically, we have all the information necessary to first solve for alpha. And once we have alpha, we can plug it back into the equation we were given to then solve for k. So our first step is going to be to determine what is our initial angular velocity and angular displacement. And basically, from the information we were given, we can deduce that when omega is equal to 0, that is our initial angular velocity. Therefore, our initial angular displacement is going to be 6. Okay, so now what I was able to do was just plug and chug, plug all of these values into this equation. We have omega is 12, the initial omega is 0, and theta is 0, and our initial theta is 6. And when we do that, we get that our alpha is equal to negative 12 rads per second squared. So now what we want to do is take this answer and plug it back into this initial equation. So we get negative 12 is equal to negative k times theta. And we are going to be using our initial theta because our alpha that we solved for was our initial alpha. So we want to keep these consistent. And also it's smart if you notice that theta is 0 here. So we don't want to use that because we'll get a 0 answer. So once we plug it into this equation, we get that k is equal to 2. And to determine the units of k, we can kind of say that, okay, alpha, the units are rads per second squared. Theta, the units are in rads. Therefore, the units of k has to be 1 over second squared. Okay, so that's our k. Now we're going to solve for the second part of the equation. They wanted to know what is omega when theta is equal to 3. And it's, again, the same equation. We have all of our variables. We're solving for omega. We have our initial omega is going to be 0. And now we have our initial alpha. We just solved for that. It's negative 12. And then you want to take the difference between the two thetas, 3 minus 6. So once we do that, we get omega is equal to the square root of 72, which is approximately 8.48 rads per second. And make sure you include the units because that's always very important. So, all right, thank you.